Hello, this is Mr. Waterman. This is Geometry Lesson 9.2, Using Property of Matrices. Today we're going to learn about a matrix, and that is a rectangular arrangement of numbers in rows or columns. And in your computer literacy class, you worked with spreadsheets using a program like Microsoft Excel, and you arrange numbers in rows and columns. So you're somewhat familiar with this arrangement of numbers. So let's deal with some terminology. First of all, rows are go across the matrix, and columns go vertically, up and down. So you might think of a column as something that would hold up a building. So maybe that would help you remember that a column is the vertical direction. Okay, dimensions of the matrix are something we're going to have to determine. So dimensions are stated as number of rows by number of columns, and we put the letter X. So we say rows by columns, but we write the letter X. So this matrix above, we have 3 rows. So going across, we have 1, 2, 3 rows, and then we have columns. We have 1, 2, 3, 4 columns. So we would write 3 by 4, or in English, a 3 by 4 matrix. All right. So if a matrix has the same number of rows and columns, what we're trying to show here, we call that a square matrix. So anything with the same number of rows and columns. So an example here is a 2 by 2 matrix. It has 2 rows and 2 columns. So same number of rows and columns is a square matrix. Okay, let's go ahead and see if we can put this to use. So first of all, looking at example 1, we have this kind of, well, it kind of looks like a rectangle, but it's quadrilateral. And we want to write a matrix that represents, first of all, point T. So point T looks like it's about right there. First thing you have to notice about this coordinate plane is that in the x-axis, each square has a value of 1. And on the y-axis, it's going up by 2's. So 2, 4, 6 are labeled there. Okay? So point T, if we write the coordinates down here, we're going to find out that it is at some value like, let's see, in the x direction we have a 3, and y we're going up 2, 4, looks like 3, 5, coordinates point T. So to put those in a matrix, we're going to go ahead and we're going to make the top row be the x's, and the bottom row will be the y values. So for 1 point, it's a pretty small matrix. We have 2 rows, a 2 by 1 matrix, 2 rows and 1 column. So we'll put the value for the x coordinate, and then we'll put the y coordinate next. This thing keeps fritzing out. All right. So second thing we're going to do with this same diagram is we're going to find the coordinates of quadrilateral TUVW. So we've set up a matrix, and we have the same 2 rows. They're going to contain the x and y coordinates, and then for each point we created a column. So the columns are labeled T, U, V, and W. So first we'll put the coordinates of point T in. So we just found that those are 3 and 5. So underneath T, we put 3 in the x column, 5 in the y column. And we're going to go around this quadrilateral and find the rest of the coordinates. So x value of u is going to be 4. Y value of u looks like it's -2. Remembering that the y-axis is, each grid line is worth 2 there. And then we're going to move over to v. Point V appears to have an x value of -1 and a y value of -2, 4, 6. So -1, -6 will be those coordinates. Alright, if Get the pen to keep cooperating, we'll be in business. So here we go. And then W, X coordinate looks like -2. Y coordinate looks like +1, because we're halfway up. So go ahead and watch part B, and we'll complete addition and subtraction of matrices.